So today we're going to be practicing rationalizing an irrational function involving radicals, but in order to do that we're going to need to multiply by a conjugate. So let's look at some examples of conjugates. Some common misconceptions are that conjugates negate everything, right? Conjugates do not negate everything, right? Do not. So all we want to do is change the sign in between the two terms. All right, so do change sign between terms. Okay, so here we have a positive 6x and a negative 3. The conjugate of this would be just a 6x plus 3. You can notice that we're just changing the sign in between the terms. But I'm not making the positive 6 negative and the negative 3 positive. No. I'm not negating everything, just the sign in between the terms. So here, the sign in between my two terms is positive, so my conjugate would be 7 minus 3i, or in this last example, my conjugate would be 4 root 3 plus 10. So everything remains the same except for that sign in between the terms. So let's get into an example. Here I have 4 over 4 root 3 minus 3. Getting rid of this minus 3, we would know, okay, I need to multiply by my foo-foo, my fancy form of 1. Same thing here, but my foo-foo is going to be a little more complex. I'm going to multiply by the conjugates. So I'm going to have a 4 root 3 plus 3, and the same thing, it's going to be a fancy form of 1, so if this is what I have on the bottom, I have to do the exact same thing on the top so that it remains like I'm multiplying by 1. So on the top of my fraction, this is going to become distribution, so I'm going to distribute my 4 to both parts. So I'm going to have 4 times 4 on the outside, giving me 16 root 3. And 4 times 3 on the outside, giving me a 12 with no root, over, and now my denominator is going to require a little bit more work because I do have a binomial times a binomial. So 4 root 3 minus 3 and 4 root 3 plus 3. Now our conjugates work out to make nice math, but we have to make sure that we recognize that pattern. So 4 times 4 gives me 16, root 3 gives me 6. 4 on the outside and negative 3 on the outside gives me negative 12 with a root 3 on the inside. Positive 3 times 4 gives me a positive 12 on the outside with a root 3 on the inside. And 3 times negative 3 gives me negative 9. So I can see when I write this out, my 16 times 3 is going to give me a 48. I have minus 12 root 3 plus 12 root 3, and negative 9. By multiplying by the conjugate, you are creating a table or a box that is going to have radical terms that cancel. Every time you multiply by a conjugate, your radicals should cancel. If they don't cancel, you've made a mistake in your multiplication, so you need to go back and check. And also, radicals should be gone because a radical times a radical, as long as it's the same radical, eliminates itself. So we get rid of all radicals in every way, and then we just simplify our like terms. 48 minus 9 gives me 39. I can check to see if I can simplify 12 and 39 or 16 and 39, but 39 is prime, so this is going to be my final answer. So same thing that we were doing in the multiplication, it's just that now we're doing multiplication in the numerator and in the denominator as far as binomial multiplication goes. So another example is when we have a binomial over a binomial, we're always going to be multiplying by our denominator's conjugate since that's where the problem lies. So I leave the 4 and I change my sign to a minus root 2, keep my 4 minus root 2. And now this is going to require a little bit of side work. We're going to need to do a box for the top and a box for the bottom. So I prefer to do my work off to the side so that I have some room, and then I put it all back together again. So we can talk about my numerators box, which is going to be negative 3 plus root 2, and negative 4 minus root 2. So our numerator isn't really going to have anything special happening. These are two different binomials being multiplied together. So we shouldn't be looking for any special patterns like we saw on the denominators box. So a negative 4 times a negative 3 is a positive 12. My negative 4 remains outside, while my square root of 2 stays inside. A negative times a negative is a positive 3 outside. A square root of 2 remains inside. And a negative times a negative is a negative times a positive is a negative. Root 2 times root 2 just gives me 2. So now when I go to simplify, I have 12 minus 4 root 2 plus 3 root 2 minus 2. And I'm going to get 12 minus 2 being like terms. So I have 10, and negative 4 plus 3 is going to be a negative root 2. So that's going to be my numerator. So I'm going to write that back at the top so that I remember that. And then I'm going to come and work on my denominator box, which will follow a pattern because we specifically want the conjugate to work out in that special way. So negative 4 plus root 2 and negative 4 minus root 2. Negative 4 times negative 4 is positive 16. Negative 4 times positive root 2 is going to be negative root 2. Negative times a negative is a positive 4 root 2. And a negative times a negative is a negative 2. Here again I have my like terms, so positive 4 root 2, negative 4 root 2 is going to cancel, and I'm just going to end up with 16 minus 2, which is going to simplify to 14. And here I double check, is there anything I can simplify? 10 and 14, yes, but because I can't simplify that with the coefficient in front of my root 2, this is going to be my final answer. So the binomial and the binomial do require two boxes, and I would recommend doing your work separately and then pushing it all back together at the end. It's going to help you from making errors. Again, your numerator won't have anything special going on. Your denominator will always have this repeater crossing out in the middle. And then the final example we're going to do is working with our imaginary numbers. We have the same process that we saw with our regular denominators. Here we're going to multiply by our conjugates, just like we did with our radicals, but we're going to have a minus 5i and negative 7 minus 5i. Again, this is going to be a distribution on the top, since we only have a monomial on the top, and then a box in the denominator, since we have a binomial times a binomial. So here I have my 8 times negative 7 is going to be negative 56, and my I comes along. 8 times negative 5 is going to be a negative 40, and I times I gives me I squared, over, and here I'm going to do my box, negative 7 plus 5i, and negative 7 minus 5i, gives me 49, negative 35i, negative times a negative gives me positive 35i, and we really have to be careful on this last box. A negative times a positive gives me negative 25i squared. So now I have 49 minus 35i plus 35i minus 25i squared. Our like terms cancel, which we're hoping will happen with our conjugate, and we really have to be careful that our negative from the multiplication is now going to get converted, because I know that I squared is equal to negative 1. So we're going to end up getting 49 plus 25, which is going to give me 74. So that becomes my denominator. But I also have to remember that I have my I squared up here as well. So to change that, this is my negative 1. Negative 1 times negative 40 is going to result in the positive 40 over 74. Now I need to double check once I've simplified everything as far as multiplication goes, check to see if I can simplify any of my coefficients. And I do recognize these are all even numbers, so I'm going to try and take a 2 out of everything. So 56 divided by 2, I'm going to have a negative 28i. 40 divided by 2 is going to give me a 20. And 74 divided by 2 will result in a 37. And now it is as simple as possible. So we will spend some more time going over this when we return. Here are 2 problems for you to check yourself with, and be ready to ask questions when we come back to class.